So, welcome to this online lecture. In the previous lecture, we have discussed 6 examples on a partition of a group. Yes, whether it is a distinguishable or indistinguishable cases are there. Now, in today's lecture, we will able to learn here a selection and combinatorial counting under some identical selection or objects. Yes, so see here, before that we will see one example on selection of a distinct books from a library. So let us see this example. A library has a collection of 8 distinct books. A reader can choose to borrow one or more books from this collection. So how many different ways can the reader make their selection? So read this example carefully. A library has a collection of 8 distinct books. Yes, a reader can choose to borrow one or more books. That we have to choose one or more books. So how many ways we can reader make this selection? So this is the question. So to determine the number of ways the reader can select one or more books, we consider the total number of subsets that can be formed from 8 distinct books. Yes. So the total number of subsets is given here. Each book can either be included in a selection or not. So there is a 2 choices per book. For 8 books, the total number of subsets is 2 raised to 8. Yes. So excluding the empty set, we will subtract it by 1. We get 2 raised to 8 minus 1, which is equals to, just you can simplify it, we get 255. And thus the reader can make 255 different selections. So are you understand this example? Yes. Now see here, the next concept is a selection of items with identical objects. So now when selecting the objects from a collection where the some objects are identical, the number of ways to make a selection is determined by considering each type of object separately. So if, for example, if P identical objects of one type, Q identical objects of second type, and R identical object of third type, so the total number of non-empty selection is given by, in bracket, P plus 1, in another bracket Q plus 1, in another bracket R plus 1. You can take the product of these 3 brackets minus 1. Yes. So this is the result to find or to select the items with identical objects. Yes. So let us see here one theorem on this one. So this is the statement of the theorem that I have already discussed these concepts. The number of ways to select from P plus Q plus R objects, where P objects are identical of one kind, Q objects are identical of second kind, and R objects are identical of third kind, and it is given by the product of P plus 1, Q plus 1, R plus 1 minus 1. And this we have to show here. So let us see the proof. So total number of selection is here for each of 3 types objects are P plus 1 choices for first type. Yes, 0 to P objects. Q plus 1 choices for second type, 0 to Q objects. And similarly, R plus 1 choices for third objects or third type, and it is 0 to R. So the total number of selections including the empty set is, just you can, for empty set you can subtract 1. So P plus 1, Q plus 1, R plus 1. So this is the selection including empty set. Now excluding empty selection, we get, just you can subtract minus 1. Yes. So this is the result we have shown here for selection of objects of for selection of items of identical objects. Yes. Now we will see here one corollary of selection with different objects. So this is the statement of the corollary. The number of ways to select from P plus Q plus R plus T objects, where P objects are identical of one kind, Q objects are identical of second kind, and R objects are identical of third kind, and T distinct objects is given by. It means that here T objects are distinct, P, Q, R are identical of first, second and third kind. Yes, and it is given by P plus 1 in first bracket, Q plus 1 in second bracket, R plus 1 in third bracket into 2 raised to T minus 1. Yes, so this result we have to show. So let us see. So for each type we will follow again the same procedure that we have already explained in the previous theorem. P plus 1 choices for first kind means 0 to P objects, Q plus 1 choices for second kind for 0 to Q objects, R plus 1 choices for third kind, it is 0 to R objects, and here T objects are remaining, distinct objects are there, that's why it is 2 raised to T choices for T distinct objects. These T objects are not identical and each can be included or excluded. Yes, and thus the total number of elements or selection of these elements including an empty set is given by P plus 1, Q plus 1, R plus 1 into 2 raised to T. After that, just you can subtract the empty set, we get the required result. So this is here, this is the result. Yes, P plus 1, Q plus 1, R plus 1 into 2 raised to T minus 1. Now see the next corollary, which is also depends on previous theorem. Selection of at least one from each group. So this is the selection of at least one from each and every group. So the number of ways to select from P plus Q plus R objects, where P objects are of identical of one kind, Q objects are identical of second kind, R objects are identical of third kind, such that at least one object of each kind is selected and it is given by P into Q into R. So are you understand here the statement of this corollary? Read again. I pause here for 10 seconds. So here P plus Q plus R objects are given. P, Q, R are identical objects of one, second and third kind. At least one object we have to select, yes, from each kind, then it is given by P, Q, R. So how to prove this one? So for proving this, P objects of first kind, we have P choices from 1 to all P objects. Similarly, for Q objects of second kind, we have Q choices, and for R objects of third kind, we have R choices. If we collect these choices, so the total number of ways to select at least one object from each group is given by P, Q, R. Yes. So this is a very obvious corollary. So in this way, we will discuss here the first theorem, or we have first discussed one example, which are a selection of distinct books. Yes. Then we have discussed selection of items with identical objects. So this is the main theorem of today's lecture, and that is if we have to collection of some objects are identical, the number of ways to make a selection, then the P identical object of one type, Q identical object of second type, R identical object of third type, then you can write P plus Q, Q plus 1, R plus 1 minus 1. So we have proved this result. After that, we have also proved the corollary selection with different objects. Means if it is given that we have to select the number of ways to select P plus Q plus R plus T, P, Q, R are identical objects of first, second and third kind, and the T objects are different, then the total number of ways of selection is given by P plus Q, Q plus 1, R plus 1, 2 raised to T minus 1. After that, we have also discussed one corollary on selection of at least one from each group. Yes, if P plus Q plus R objects are there and all these objects are of identical of first, second and third kind, then if we have to select one object, at least one object from each group, then the number of ways is given by P, Q, R. Yes. So today we will stop here.